Yo, I wanna die. Anyway, so, for terrain model, I only got tasks 1 and 2 done, because there's some major upbringings that occurred within. Whatever, we'll get there when we get there. So, essentially, here's my model H, based on the game logic. Yeah, I know, game logic, whatever. The alternate way is make it a line 16 and then take from drawable and collidable eventually. Either way, so I have find cell, pixel index, which is technically pixel index now, I just was lazy. Cell index, there's the draw, there's update, entry for scene, find a cell square, this is used for task 2, and display square is also used for task 2. Game objects, use wire version, C index, image height width and cell width, bunch of stuff. Compute cell data is the most important there. So starting from the top, here's the actual terrain model. This rest row call basically sets up my max and min for the row and column to be the lowest I can. Offset, I was fucking with this, but I'll probably reuse this later. Right now it's just identity. There's the image data, fun stuff. More fun stuff there. Here's the making the verts. Here's creating your anchor by setting it to the very first vert when you're done with that list. There's some weird shenanigans that was going on through discussion. Basically, I reverted some old code into it instead of using a nice vertex index. Throw that all into compute cell data. Make your model. Send it. Destroy the lists. There's your rest call. Here's the pixel index, something called pixel index. It's every third since RG, the A in RGBA is not there. Here's cell index. Here's just the draw, the registrations. Here's the compute cell data. Take the midpoint. Literally, it's just grabbing the Y essentially from all of it, from the four corners. Here's find cell. It returns a cell index, so this would be for the very center of a model. This compares it to the maximum and minimum of that square, and since we're using the get max and get min of a B sphere, it's doing essentially a flat ABB, and then display just goes through the list and visualizes it. So I'll play that real quick. While this is playing, yeah, it was fucking harsh, dude. All that's really been there's nothing really new for the game itself, but as you can see, there's my tank in all of its glory, floating around. But yeah, so I guess math-wise, so I talked about having an angle of incidence being used for armor penetration, and originally I was going to use Snell's law for that, but then I realized I have no angle of reflection to throw into that to find the angle of incidence. So instead, it's just a slight modification to the determining if a point is within a view cone, and instead of comparing the left side of that problem to cosine of theta, it's solving for theta instead of comparing it. So then it becomes theta equals that inverse cosine of the dot product. Yeah, the dot product of the vector, which is going to be the normal of that tangent, and then the point and that origin of the tangent. And yeah, that's the math for that. It'll be a costly thing, so I'm rewriting this bit here. Oh, you can't see it because I'm actually writing. But basically, I'm going to only have that applied to the enemy tanks with the player, and since the player can only fire one bullet at a time, it'll only occur for the armor-piercing rounds instead of the flak rounds. Yeah, whatever, dude. It's bad. Oof.